Okie dokie. So here we go, number 1. Find decimal degrees. Paige, you already have it done. Tell me what you did, Paige.
I did put 136 and then did the second apps thing to get the degrees, then 12 second apps again, and then 19 alpha plus sign.
Perfect. So she just typed in on her calculator exactly what she just said. So, good job, Paige. And did you get 136 point? Does it tell me how to round? No, let me look at the quiz and see if I have you rounding. 1,000. Okay, so we'll just practice rounding 1,000 for 136.205.
Yes.
So the angle that's in pieces like that, you literally type in pieces. So 136 degree, 12 minute, 19 second equals. Got it. Okay, number 4, no calculator for this one. How do we change radians into degrees? There's lots of ways. The way I've been doing it, the way that I always do it is pi is to 180, S4 is to X. Now, why is the 4, this will never change, pi over 180. Why is the 4 on the top of this fraction? Why is it 4 over X and not X over 4? Eli?
Because the radians are on top.
Exactly. That's a radian, that's a degree. This is a radian, I'm looking for the degrees. So pi x equals 720, 720 over pi degrees. Now this is a no calculator problem, so obviously we're gonna leave it just like that. You're not gonna mess with that at all. You don't really need a calculator for this one, but if you use it, west, northwest. So here's west and here's north. This would be northwest. Everybody agree? Now, when we put that third letter in there, it means we need another division. We either have the purple division or we have the orange division. If it's west, northwest, which one is it? Purple. So this is the angle that will answer the question. Remember, north is 0, and that's where you start. So you just keep going and going and going till you get where you want to be, which is right here. So when I start dividing all these are 22 and a half. Remember that? Half of 45, which is half of 90. So 270 plus 22.5, I'm saying 292.5. What are you? Are you with me on that? Now, number 4 is kind of the opposite of number 1. For number 4, we're going to type it right in, 78.136, and then second angle DMS. So I got 78 degrees, 8 minutes, 9.6 seconds. How's that sound? So for problem number 1, we have to put them in individually and label them. For problem number 4, we just type in the whole shebang and hit DMS. Number 5. Number 5 is exactly like this one right here. So if you want, you can say pi over 180 equals, now, I've got 315 degrees. So So where does the X go and where does the 315 go? X on top, 315 on the bottom, absolutely. So 180x equals 315 pi. So 315 pi over 180. Now that is the answer, but we probably should reduce it. And they're both divisible by 5. So if I had my calculator, I'd just type it in, but I don't. So 63, 180 divided by 5, 36. Oh gosh, those are still divisible by something. 9. So 7 pi over 4 is your final answer. Now, I don't want you to sweat that reducing, kids. Truly, you should be able to do that. But this is the main part right here. You need to reduce, but I don't want that to cause you great anxiety. Next question talks about an arc. So here's my arc, right here. This is my arc. And it is 38.6 inches long. Find the radius if the central angle is 1.4 radians. What's my handy dandy little formula? Radius times radians is arc length. Now that formula is the same as r theta, I think is the way. It's the same as S equals r theta. So those of you that use this version of the formula, that's perfectly okay. It's same, it's fine. But you do need to remember that theta has to be in radians, okay? Well, it is, so I'm good. So 38.6 equals r times 1.4. So r equals 38.6 divided by 1.4, 27.571 inches is the radius of the circle. Anybody have a question about that? Okay, before I erase this problem, if this angle had been given, let's say it was 14 degrees, if it had been given in degrees, then you can't do this. You have to do this first and get a radian, and then you do this. So it becomes a two-step problem. Got it? Okay. All right. What's next? Evaluate with calculator. So I'm just going to type these in on my calculator. Please pay attention. See that right there? I'm going to make sure my calculator is set in degrees because that's a degree. Now, how am I going to type a cosecant in on my calculator? 1 divided by sine. So 1 divided by sine 10. Did you get 5.759? Remember, these can come out negative. That one didn't, but it's possible for them to be negative, so don't panic if they are. Now, before you type this one in, see what's not there? So you're going to have to change your calculator into radians. It's a pain in the butt. So tangent 1.87. Oh, there's a negative. Negative 3.242. Everybody okay? Okay. Next, we've got a little picture here. And we need to solve for x. So, we're gonna write an equation. But before we write it, we gotta figure out if it's gonna be sine, cosine, or tangent. So, what do you think? Why? You're right. Somebody said cosine and you're right. Why?
Because you're trying to get adjacent and you have a hypotenuse.
This is adjacent and this is hypotenuse. So your equation is gonna be cosine 17. Always put the angle with the cosine or the sine, whatever it is. So cosine 17 equals x over 28. So that's an easy one. Caution, caution, gotta be in degrees. So 28 cosine 17. I got 26.78. Everybody okay with that? All right, let's turn it over. No calculator. Find theta in degrees, and we know sine theta is √3 over 2. So I'm going to draw this triangle. When I'm left on my own, I always draw that triangle. That's the triangle to draw. If you, like here we already had one, great. If you don't already have one, go ahead. Makes sense to draw a triangle because isn't this opposite over hypotenuse? So I might as well have a picture to look at. This is my angle. The opposite side is √3 and the hypotenuse is 2. You with me? So I don't really need it, but this side would be 1. How big is that angle? It's across from the √3. How big is it? 60 degrees. Now for tomorrow's quiz, I'm going to let you use your purple sheet as long as you have a written sheet stuff on it. I'm going to let you use it, but I will be weaning you off of that. You've got to be memorizing this stuff, okay? There's a lot, but you just have to do it. So that's a 60-degree angle, and that's the answer to the question. Find theta in degrees, 60 degrees. Okay? Same thing. Cotangent equals 1. This time I'll answer in radians, but that doesn't matter how, that doesn't change the way I do it. I need to figure out what angle has a cotangent of 1. And remember, you can always turn those into fractions because they're all fractions. So cotangent what's the 1 and the 1? The 1 and the 1 are adjacent and hypotenuse. Remember, this is reciprocal of tangent, and tangent is opposite over adjacent, so this guy is adjacent over opposite. Not that it matters, but this side would be √2. And how big is that angle right there? 45 degrees. if you say 45 degrees, you're gonna get most of the credit, but that isn't how you're supposed to answer. You're supposed to answer in radians. So you can either intuitively think about it, or you can say pi is to 180 as what is to 45. You don't have to set up that work. Some of you are gonna say, wait, 45 is a fourth of 180. You're right, it's pi over 4. But if you work it out, you're gonna get exactly the same thing. You're just gonna reduce that fraction and get pi over 4. Just like 60 would be pi over 3 because it's a third of 180. But I could work it out like this if I wanted to. All right, anybody have a question about those two?
So, we couldn't put 4 radians, we would have to do pi over.
Pi over 4. Yep, pi over 4. This one is 60 degrees, that one's pi over 4 radians. All right, find the exact value. So this is the opposite of what we just did. So you got a tangent pi over 3, and you have to tell me what fraction it equals. What's pi over 3? 60. So here's my 60. Pi is 180. 180 divided by 3 is 60. Now, you're supposed to know the sides of this triangle. Across from the 30 is 1. Across from the 60 is root 3, and the hypotenuse is 2. This is your angle, always at the origin, and you want tangent. What's tangent? Opposite over adjacent, so that will be root 3 over 1, or just plain root 3. And then secant pi over 4. I'm gonna cheat a little bit. Isn't this the triangle for 45 degrees? Pi over 4. And I want the secant. What is secant? Reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So root 2 over 1, or root 2. All right, here we go. Where do I go from there? Kate?
The hypotenuse, if we do a squared plus b squared equals c
So
squared.
Katie says, from the given, I know opposite is 1 and adjacent is 5. So she's gonna do the Pythagorean theorem to find her hypotenuse. So it looks like root 26. Here we go. Sine is opposite opposite over hypotenuse. Cosine is adjacent over hypotenuse. These are the reciprocals. Cosecant is sine, secant is cosine, and cotangent is tangent, reciprocal. Once you get all that done, go back and clean up anything that needs cleaned up. So things like 5/1, that's just 5. Root 26/1, that's just root 26. Radicals in the bottom, don't like them. Clean them up. And these are my final answers then. Anybody have an issue there? All right, last one. We got a bird in the top of a tree. Here's the bird, here's the tree. The tree is 13.5 feet. Spies a worm on the ground. How far will the bird have to fly to capture the worm if his angle of depression is 5910? Remember what we talked about? This is where we're gonna put our angle of depression or angle of elevation, right? That's where you're gonna put it. No confusion, don't mess with it. Put it there. Whether it's elevation or depression, they're the same, they're equal. Where's my X go? How far will the bird have to fly? Isn't that the hypotenuse? Isn't that where the bird's flying? All right, write an equation, need sine, cosine, or tangent. What have we got? Sine. So sine 5910 equals 13.5 over x. I need to see this equation, guys. Some of you are good enough, you can get straight from here to here, you don't need that middle step, but I do need to see that equation right there. That's your work. So what do we come up with? I got 15.722 feet. On your word problem, be sure you're putting a unit on it, okay? Well, we just finished.
Thank you.
All right, everybody okay with that? So, tomorrow we have a quiz. Quiz gonna have problems that look like this, may not be this many. Every problem on the quiz is represented here. Tomorrow, probably for the last time, you can use your purple sheet. After that, it's gotta be memorized, okay? It's time. We're moving on. All right, now, let's get our notes out. And pick up where we left off. Which, if my records are right, page 43, number 2. Is that right?
Yeah.
All right, here we go. We want to find a positive and a negative coterminal angle. What in the world am I talking about? Okay. First of all, I need to know what 100 degrees looks like. Now, I know what 100 degrees looks like navigationally. This is not navigation. This is straight math. There's no directions here. There's no boat. There's no airplane. This is just straight math, 100 degrees. When we label 100 degrees, if it's not navigation, we start here, this is 0, and we go this way. So 100 degrees would actually look like this. Don't tell me it's confusing. I didn't write the rules. Navigation is its own animal. Every other angle you ever draw in your whole life is going in math class is going to look like this. 100 degrees is going to look like this. So we start right here, 0, positive x-axis, and we rotate counterclockwise. That's 100 degrees. Now, coterminal means, is there another angle that I could start here and stop here, just like I did with 100? Is there any other angle that would do that?
Would it be like the reverse?
Oh, would it be like this one? Well, what would be the measure of that angle? If the black one is 100 degrees, what would be the measure of this purple one?
260.
Not two, oh yeah, 260? Only it'd be negative. Why is it negative? Because when you rotate in this direction, your angle is negative. This is a positive rotation. Counterclockwise is positive. When you rotate this way, your angle is negative. Since a full revolution is 360, does it make sense that if that's 100, that one's 260? Yep. Now, the math behind what Robbie did was he said, look, take your 100 and subtract 360. That will give you negative 260. What if I took my 100 and added 360? What would that give me? And what would 460 look like? If I graphed 460 degrees, what would that look like? Well, wouldn't it go all the way around? And then 100 more? So doesn't the orange angle also start and stop in the same place? Those are called coterminal angles. They have the same sides. They start and stop in the same place. Now, we got Robbie's angle, which we took 100 minus 360. We got mine, where we took 100 plus 360. Is that it? Are those the only coterminal angles, or could I somehow draw other angles that start and stop in the same spot? You could just keep going. So in other words, I could take my 100 and add 2 360s. So spin, spin, and then 100. Or I could subtract also, right? Like Robbie did. And that wouldn't have to be a 2. That could be a 3 or 4 or a 10 or whatever I wanted it to be, right? So, the smallest positive coterminal angle is 460. The smallest negative coterminal angle is negative 260. But there are infinitely many other coterminal angles. And we would write those exactly the way we just did, except since this number could be anything, could be 2, it could be 3, it could be 4, I'm just going to call it n. And that describes, if I let n be a whole number, like 1, 2, 3, 4, 5, 6, This describes 100 plus 1 revolution, 100 plus 2 revolutions, 100 plus 3, and so on. But it doesn't have to be plus, it could also be minus to get the negative coterminal angles. So this is all of them. Usually you just want one. So you would go for the smallest positive and the smallest negative, one of those, whichever one you wanted. This is all of them. Zillions. Okay? Okay. All right. So there we answered that. Find one positive, let's do negative 150 next. Negative 150. We're gonna find one positive and one negative coterminal angle. So how do we find coterminal angles again? We either add or subtract a revolution. So can you give me a positive coterminal angle for negative 150?
110.
210? Don't we add 360? Wouldn't that be 210?
Yeah.
And then subtract 360, what is that? Negative 410? Oh, 510? Guys, how do you find coterminal angles? You add 360 or you subtract 360. Period. That's it. Now, what's the problem with letter B?
It's in radians.
It's in radians. Now, the strategy is not going to change. You're gonna take 2 pi over 7 and you're gonna add something and you're gonna subtract something. Now, what are we gonna add? Please don't add 360 because 360 is a degree. But why is it 360? What does 360 represent? A revolution. So in radians, what's a revolution?
2 pi.
2 pi. 2 pi. Pi is 180. So 2 pi is 360. So we're going to take our 2 pi over 7 and add 2 pi or subtract 2 pi. To find coterminal angles, you add and subtract revolutions. So in degrees, that's 360. In radians, that's 2 pi. So I'll get a common denominator here. So 2 pi over 7 plus 14 pi over 7. So my positive coterminal angle is 16 pi over 7. 2/7 plus 2. Get a common denominator and add. And then same thing here. So 2/7 minus 2. Negative 12 pi over 7. So there is your positive and negative coterminal angle. One more time. How do you find coterminal angles? Add and subtract a revolution. So 360 or 2 pi, depending on if you're in degrees or radians. Okay? Right now you're thinking, what does this have to do with anything? You will find out. You will find out. Coterminal angles are very important. All right, next section. Next section says simply, find the sine, S-I-G-N, of the sine, cosine, and tangent of an angle in the given interval. Now, we're not doing navigation. We're doing regular math. So this is 0. Remember, we rotate counterclockwise. So if this is 0, what's this? 90.
180.
Right? Now, in radians, 180 is pi. So 90 is half a pi. And 270 is 1.5 pies. of course, all the way around is 2 pi. So when they say you're between pi over 2 and pi, would you agree that's being between 90 and 180? So you're over here somewhere in this quadrant. Remember our butterfly bow tie we talked about the other day? So I'm somewhere in this quadrant. I have no idea how long these sides are, but I know whatever they are, this one is negative, this one is positive, and this one's always positive. Look at where you are, quadrant 2. X is negative, Y is positive, hypotenuse is always positive. Now, tell me about the sine, cosine, and tangent. I don't know numbers, I know no numbers, I just plus or minus. What's sine? Opposite over hypotenuse. So opposite over hypotenuse will be plus over plus, which is plus. What about cosine? Here's your angle. Adjacent over hypotenuse. So it's going to be negative. And what about tangent? Opposite over adjacent, so it's going to be negative. So in quadrant 2, sine is positive, but the other two are negative. That isn't something you want to memorize. You want to memorize the purple sheet. You can figure this out, just like we did. All right, where's pi to pi over 2? Where am I talking about there for this next problem? I have to be between pi and 3 pi over 2. Isn't that here in quadrant 3? Tell me about this side right here. I mean, this is the origin. Tell me about this side right here. Negative. What about this side?
Negative.
And this is always positive. That one never ever changes. Hypotenuse is always positive. Here's your angle. Sine, opposite over hypotenuse. Did you get negative? Cosine, adjacent over hypotenuse, another negative. Tangent, opposite over adjacent, it is positive. No calculator. Without a calculator, can you tell me whether these things are positive or negative? I don't need a number, I just want to know plus or minus. So let's just think about them for a second. Usually the degree ones are easier, so let's start with the degree ones. So that's D, E, and F. And let's remember that in math land, these are our labels. So where is 152? 152 is in quadrant 2, perfect. This is 152 degrees, would you agree with that? So what do I know about my triangle in quadrant 2? I know negative, positive, positive. Sine, I don't know any of the side lengths, I don't need to, I just want to know positive or negative. So what sine? Sine is opposite over hypotenuse. So won't that be positive? Positive over positive? Negative 200. Now remember, negative means that we rotate down. We go this way. So negative 200, would that also be in quadrant 2? Because this is 180, I threw a little bit past. Now I want the tangent. Tangent is opposite over adjacent. So opposite over adjacent will be negative. Whoa, 500. 500. This is where your coterminal idea can come in. What do we know about 500? It's more than once around, right? So let's just get rid of that extra part. Let's just take out that extra 360. This is really what angle if we take out the extra 360? 140? Oh my gosh. Isn't 140 also in quadrant 2? Secant. Reciprocal of cosine. Cosine is adjacent over hypotenuse, so that one is going to be negative. We're watching the clock.
I got a question.
Yep.
How do we get 140?
500 minus 360, right? It's more than a revolution, so we'll just take out the extra revolution. You can leave it in there, but then when you draw it, you just have to go all the way around. All right, now we're going to do the radian ones. Now you can obviously change these into degrees if you want. So this would be 8 times 180 divided by 9. You can absolutely do that. Now these are no calculator problems, so if you're going to change it, you're going to change it on your own, doing your arithmetic. How about though, if we just kind of use our common sense? If we go back and relabel these with the radian measures, remember 0, 0. This is pi, because it's 180. 180 is pi. This is half a pi, and this is 1.5 pies, and then this is 2 pi all the way around. Pi is 180. 90. 270. So where would 8 pi over 9 fit in this? Remember, you're going this way, going around. Where would 8/9 pi be? Oh, guess what? It's in quadrant 2 again. There are angles that aren't in quadrant 2. I don't know why this is happening, but anyway, this one's in quadrant 2 because 8/9 is a little bit less than 1. So cosine will be negative because it's adjacent over hypotenuse. Okay, finally, I have one not in quadrant 1. Negative pi over 7. First of all, negative means this way. Each quadrant is half a pi. Is pi over 7 more than a half or less than a half? Less. So wouldn't pi over 7 be right here, negative pi over 7? Which means positive, negative, positive. We want the cosecant, which is the reciprocal of the sine. So we need opposite and hypotenuse, that is going to be negative. Twenty-five pi over 8, whoa, 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 that's a big angle. Anybody have an idea about a mixed number? What's 25/8 as a mixed number? 3 1/8. Now remember, all the way around is how far? All the way around is 2 pi. So is this more than all the way around? This is all the way around and an extra what? How much extra do I have after I go all the way around? 1 1/8. So I'm really just gonna think about 1 1/8 of that. Because the extra 2 pi is just a spin, right? Where would 1 1/8 be? 1 whole pi is here. And then wouldn't an eighth be just a little bit beyond that? So here's my angle. This is a quadrant 3 angle. Negative, negative, always positive. Cotangent. Tell me about the cotangent. Reciprocal of tangent. So opposite and adjacent are involved. So that's going to be positive. All right, tomorrow we start the big time stuff. We're pretty much through all the basics. We're ready to start doing it. Good work. Lots going on here. Quiz tomorrow. Everybody knows what's on it. Everybody knows what the expectation is.